So we're back with 6.1. We talked about monomials, binomials, trinomials. Now we're going to be evaluating polynomials. Now remember, a polynomial is an expression. It's not an equation. There is no equal sign within this problem right here. So it is just an expression. Now what they're asking you to do is tell me what is the value of this expression if x equals 2. So this is going to kind of take you back to module 50. DMA 50, whenever you have x equaling 2, well, let's just plug them in and let's see what do we get. If x equals 2, what is this value? So I have 3 times 2 plus 5. 3 times 2 is 6 plus 5, so my total value should be 11. Okay? Similarly, if I have 2 minus x to the third, what is that value? Evaluate that when x equals 4, let's say. So again, I'm just going to plug it in. Kind of like a little Glade plug-in song. Just plug it in, plug it in. Alright, so we'll just plug it in. So now I have 2 minus, I have a 4, and that 4 is the third power. So you got to figure out what is 4 times 4, it's 16, times another 4. I believe that's going to be 64. So I have 2 minus 64. Use a calculator if you need to. Because 2 minus the 64, that should give me a negative 62. Okay? So again, just plug it in. Notice this problem's a little different than the one in your notes, so don't get thrown off by that. Okay? Alright, so that is evaluating. Plug it in. See what you get. What is your value? Alright. We're going to talk about identifying terms. Now, if I were to talk to you about 5 minus 3, we all know if you have 5 fingers, and you were to take 3 away, you've got 2 left. Been doing that since elementary school. Well, interestingly enough, this problem can be rewritten. And as we move through the math and get into more complex equations and expressions, you will find that minus symbols can hide a negative. Check this out. I can take this minus, and there's rules in math that say I can change the minus to a plus if I change the number after it to its opposite. Is this still a true statement? 5 plus a negative 3, yep, that still equals 2. So anytime you see a subtraction symbol, let's say you were to have 9x to the third minus 4x to the fifth, I want you to see, can you get rid of that minus? So I can change a minus to a plus if I change the number after it to its opposite. Kind of cool? What if I were to have 3x minus a negative 5x? So I can change my minus to a plus if I change the number after it to its opposite. So now that can be rewritten as 3x plus 5x. Okay? This actually segues us right into the next idea, which is combining like terms. Okay? So let me get rid of this for a second, and let's talk about if I were to give you 4x to the third plus 5x minus 4x squared plus 2x to the third plus x squared. Looks really, really messy. If I were to ask you to just simplify this, before we do that, how many terms do we have? Well, remember, we can divide the terms. We can separate terms by plus or minus. So that's going to separate my terms. So I have 1, 2, 3, 4, 5 terms. Kind of cool. Alright, so now if they're asking me to simplify or combine like terms, I got to figure out what's alike. And the way you're going to do this is you're going to look at your variable and his exponent. Where else do I have x to the thirds? Well, I have an x to the third over here. So I have 4 of these x to the thirds and 2 of these x to the thirds. So 4x to the third plus 2x to the third gives me 6x to the thirds. Okay? And then as I keep going, I can see that, let's look at my x squareds. There's some x squareds and there's some x squareds. So here, check it out, I have a negative 4x squared. Now this is where you may want to change and get rid of that subtraction symbol, because this is actually, I change my minus to a plus, number after to its opposite. Now I can see that's actually a negative 4x squared plus, there's an understood 1 there. So negative 4x squared plus 1 x squared is going to give me a negative 3x squared. And then finally, I want to look at my just x's. And notice how I put squigglies to kind of help me eyeball and match up what I've got. So this is my only 5x. It's my only just x. So I'm just going to say plus my 5x. And this would be my simplified answer. Okay? Now, this kind of leads us into the next idea, which are coefficients. Now, a coefficient is really the number that's being multiplied by your variable. So in this case, that is a coefficient because 6 is the number being multiplied by that variable. In this case, what is my coefficient? Be careful, it's not 3. Remember, this minus can hide a negative. So that's where, again, you might want to change my minus to a plus, the number after into his opposite, and now I'd say, ooh, his coefficient is actually negative 3. His coefficient is a 5. Okay? Remember, these guys are coefficients. These guys are your exponents. And his exponent is to like the first power. It's understood to the first. Okay? So these are my exponents. Down here in black, I've highlighted my coefficients. All right? One last thing I want to show you before we erase this problem. This problem is written in descending order. And that's how you want to simplify your answer with polynomials. Notice again, if I look just at my variable and exponent, I have x to the third, x squareds, and now these are x to the first. So if you were to be given a problem, and let's say I were to give you 2x to the fourth minus 8x to the third plus 5x squared minus an x plus 3, and I asked you to rewrite this problem here in descending, I already wrote it in descending order. I didn't mean to give you the answer. But notice this is in descending order because if I look at my variable and the exponent, that's all I care about for descending order. So I have my x to the fourths, x to the thirds, x squareds. This is like x to the first, and this is a crazy idea here. This is actually an understood x to the 0 because as we will study, anything to the 0 power equals 1. So if I were to say 3 times x to the 0, which is 1, isn't that the same as just 3? So anytime you see just a number, just a constant, there's an understood variable to the 0 power, okay? Because that doesn't change its value. If this totally goofed you up, it'll make a little more sense as we get into our exponent rules later. Just wanted to kind of plant that seed, okay? So remember, coefficients are the number before the variable that's being multiplied by the variable. They're important. You use those to combine your like terms. Whenever you're adding like 4x to the third and 2x to the third, you're actually adding your coefficients there. When you're writing it descending order, you don't worry about your coefficients. Rather, you worry about your variables and exponents and putting those in descending order. So that's biggest down to smallest. Okay? All right. Couple more ideas for you here. Okay. Actually, let's go ahead and pause here and then we'll have a part 3 of the video.